Hello everyone, I want to welcome everyone to this section of my video to cover our control blasting under the subsection pre-splitting. So um, I've explained in the previous live video pre-splitting, but I was unable to save it for the sake of others. Um, so I'm doing this again. So control blasting, as I've explained in my previous video, is performed majorly just to control the quantity of energy that interacts with the rock. So most of the blasting that is being carried out in the mine is carried out for mainly the production of crude, so as to supply raw enough mine, the processing plant, and we are interested in getting the highest grade of extracted from the rock, in situ rock. So we are not interested in blasting the rocks that are barren and getting all those rocks that are containing less of all grades that are being diluted uh, with those that are of low grade. So we're interested in controlling dilution so as to control the cost of processing and the cost of production. So in a bid to ensure this, therefore we need to put control blasting in place. Also, we are interested in safety in the place of ensuring that the wall that is left after the blasting is a highly stable rock that can withstand distribution of stress during loading, distribution or redistribution of stress during blasting, so as to ensure that the wall is safe. Then we are in need of control blasting to ensure that enough the energy that is interacting with the rock wall is not such of energy that will create more of discontinuity into it and render it unstable. Also, in the place of ensuring that the environmental impact of blasting is minimized. That is, we ensure that we control the blast such that the blasting is having less of ground vibration, less of air blast, less of fly rock to the community, to the environment, which can create a lot of accidents for the mine workers, even to the equipment. So, in a bid to ensure high safety, also there's a need for control blasting. Control blasting is to reduce the level of accident, to reduce the level of fly rocks, to reduce the level of rock wall damage, to reduce the level of the dilution during blasting, and especially in the case of open pit mine where we are interested in a specific bench height at a time. So I've mentioned earlier some of the techniques that is used for controlling blast energy that interacts with the rock. I made mention of line drilling. I make mention of ear decking blast. I make mention of smooth wall blasting. I make mention of pre-splitting and post-splitting. But in this video, I'll be explaining pre-splitting techniques first. I'll be explaining pre-splitting technique first. For the sake of those people that are watching my video for the first time, by name, I'm Giant Miner, and I release most of my video on blasting and mining related activities. So here in this video, I will divide sometimes just for the sake of those people that are not a mining engineer. Lex, my video is restricted to those people that are mining and a blasting engineer. In this video, I will be making use of terms like pre-splitting, of which I will define when I get there. I'll be making use of terms like blasting, which is the use of explosive to break down rock mass into smaller particles. I'll be making use of explosive, which is a chemical composition compound that is capable of releasing large amount of energy at instantaneous detonation. So I'll be making use of spacing, which is the distance between rows of holes in a rows of hole. That is, spacing is the distance between two holes that is existing on the same row. So I'll be making use of boarding, I'll be making use of another times, and every other times that I make mention, I will ensure that I define it for the sake of those people that are following my video and are watching me right now. So pre-splitting, as I've explained earlier, that is one of the techniques for controlling blasting. What we are interested in controlling is the quantity of energy that is being released at once, and the quantity of energy that is being released from the explosive during a specific blasting. So the higher the quantity of explosive that is being detonated, the higher the quantity of energy that will be released. I explain in some of my video that detonation, blasting, at during blasting rather, or at detonation of explosive, two form of energy is being released. We have the shock energy, which constitutes the detonation pressure, and we have the gas energy, which constitutes the explosion pressure. The shock energy function in the place of fracturing the rock, in the place of creating cracks into the rock, while the gas energy perform the place of breakage, explosion. So it explodes the rock that have been fractured already so as to break it down and to bring it down flat, creating more piles. So in this case, control blasting is still interested in causing explosive to release these energies, but is interested in making the explosive to release the maximum energy that is required to perform the maximum work without damage to the rock wall, without damage to the environment. So because of this, the quantity of explosive, the spacing and the blast design, and also the sequence of initiation and the timing is different for this case in the case of pre-splitting. So because of what we are interested in, because we are interested in less amount of energy with performing the maximum work, we are interested in making the energy to perform just the blasting without damage. So these three or four things that I've mentioned is differ, makes pre-splitting blasting different from every other blasting or common blasting that is being performed in the quarry, that is being performed maybe for primary or secondary blasting in the mine. So pre-splitting is interested in making use of spacing, making use of loading weight of explosive, making use of initiation pattern and techniques to control the energy release per time. So in this case, how does pre-splitting charging density or charging weight differ from every other form of blasting? In pre-splitting, what tends to calculate the weight of explosive to be loaded into each hole with this following formula. The weight of explosive in each hole is equal to the diameter of the hole square all over 28. This is just one of the formulas. There is many diver formulas, but I think this is the rule of thumb. So this will give you the weight of the explosive that should be charged into the hole, and the charging system for this so-called pre-splitting techniques is differ. We thanks to decouple the hole. uh, as I've said, decoupling is the use of explosive of lesser or explosive cartridge of lesser diameter, whose diameter is lesser than the hole diameter. That is, when the explosive is dropped into the hole, there's still allowance. So this allowance tends to create a barrier, like it tends to to stand in between the explosive and the rock wall. So it stand as a barrier that reduce the energy released from the explosive because of the reduction in the sonic velocity of EA. So EA tends to stand as a barrier uh, to suppress the energy before getting to the rock. So due to this decoupling approach, decoupling techniques, it tends to reduce the energy that will be released from the explosive, even despite that the explosive quantity is reduced. So also, in the place of the functionality of the ear, that is the space that is left between the explosive cartridge and the rock wall, it tends to perform, like for example, this zeroth law of thermodynamics that states that three bodies having different temperature capacity or temperature range or temperature degree Celsius tends to distribute energy between themselves. That is energy from let's say body A, body B separated by body C tends to interact with each other. So the same thing as the explosive A and the rock wall B is being separated by the ESC. So the ESC tends to be as the bridge between the explosive energy and the rock wall. So it tends to absorb the energy first before releasing it to the rock wall. So as I've said earlier, pre-splitting is interested in creating a smooth wall and a stable wall after blasting. So for us to achieve this, as I've said earlier, we'll make use of one, the quantity of explosive in the sake of the weight of explosive that is charged into each holes. We'll make use of that. We'll make use of the spacing. We control the spacing and also control the detonation sequence. So in the case of the spacing for pre-splitting tanks to be wider compared to other blasting. What the spacing does is that it makes the rock block that to be blasted by a specific hole to be more higher, that is more barrier, more burden is created on each of the holes per time. So the spacing for pre-splitting tends to stand as a resistance, that is as a resistance that will absorb the explosive energy before getting to the rock that we are not interested that we are not interested in breaking. So we are not interested in the explosive energy getting to a particular rock, that is creating discontinuity in a particular level. So since we are not interested, then we tend to produce a lot of allowance between the point of initiation of the explosive, that is the charge point, and the wall that we are not interested in fragmenting. So the spacing of a common pre-splitting blast design is calculated by this rule of thumb. Spacing is equal to the um, diameter of the hole. So times 10 or times 10 to 15. So it's range. So the diameter of the hole being to be charged multiplied by 10, or a specific constant depending on the nature of the rock, the geological condition of the rock. So, but commonly its spacing equals to 10 times the diameter of the hole. So we thanks to, and also there are other means of selecting spacing for pre-splitting, like the use of the Konya constant. The Konya constant tends to make use of the spacing in related to the specific gravity of the rock. You can study Konya work in 1963. You can study that to understand how Konya constant is used for selecting spacing for blasting. So it tends to make use of the specific gravity, as I've explained, the specific gravity or the density of the rock to select the spacing of the rock based on the charge weight that to be used for the pre-splitting blasting. So spacing is very important in controlling blasting, as it's been incurred in pre-splitting. Another thing that is being used for pre-splitting blast control is what is called the initiation sequence, that is the initiation timing, that is the time at which each of the of the load holes will detonate. In pre-splitting, the hole is divided into two. We have the control holes or the perimeter holes, and we have the production holes. The production holes are the holes that is drilled into the rock block, that is the rock formation, the rock block, that to produce the mineral that we are interested in. What I'm trying to say is that, for example, in a situation where gold is being mined, and the gold exists in a quartz vein and is cutting through a pegmatitic rock or a pegmatite. So the pegmatite itself is having a zone that is having high gold nuggets, that is high gold concentration. So the portion, the block of the pegmatite that is having high gold concentration is where the production hole will be placed. That is the holes that will produce the gold crude that is to be milled or to be processed. So the production holes are the holes that we are expected to load more, that we are expected to create more of the fracture that will produce the material that will need to move down to the beneficiary plant. So, and also we have the perimeter or the control holes. The control holes are the holes that are placed in between the production block and the blocks that we are interested to live at the support or to live at the unblasted rock. So the control hose is just like the bridge, like the hose placed in between the production zone and the unproducing zone. So the control hose is that which is going to be the loading techniques to use for this production hose is different from that used for the control hose. So the control hose have more of the blast the explosive in itself in a specific quantity compared to the production hose. So we use well, in the attempts to initiate the hole with tanks to initiate the control hose before the production hose. That is where the name called pre-splitting started from. That is the main origination of the